Hi guys, you're welcome to my channel. Today I'm going to be taking you through the alternative to practical as a GCE student. And I want you to pay maximum attention to the class because you should be able to undo any alternative to practical after this class. Remember, you're taking GCE, right? And GCE practical is not practical you're going to do in the lab, is absolutely alternative. And many of us are not exposed to that before, but this video will simplify everything that has to do with alternative to practical. I will explain explicitly so that you are going to understand it in detail. Now, what do you need when you are going for alternative to practical? You need a complete mathematical set and a long transparent ruler. That is this, a long transparent ruler. It should be transparent. So those are the things you need when you are going for alternative to practical exam. And the last thing you need to go with is your confidence. You need to be confident, and that's why this video is going to take you through everything that you need to know whenever you are doing alternative to practical. And I'm going to suggest, if you want to practice, if you also need all of these questions to practice, you can just let me know in the comment section. If you are new to this channel, don't forget to subscribe, like the video, and share within your friends, because it will allow YouTube to suggest the video to every other student who are in need of this particular one, video, in order for them to do well in their physics practical. So without any further ado, let's get started. Guys, so we want to start to read the question now. Now, whenever you want to start the alternative to practical, the first thing you want to do is to read the question so that you're going to have the overview of everything the question is all about. So that's the first thing you're going to do. So let's do that together. An illuminated object O is placed in front of the reflecting surface of a concave mirror M. This is the illuminated object, and this is the concave mirror. You can see it's placed in front of it. This is the shiny part of it, and this is the back of the mirror. Although you don't really need to know much about this, just for you to understand the diagram. That's what I'm showing you all of this. The position of the object is adjusted until its sharp image coincides with it. So what this says is that the position of this object is what they keep adjusting until the sharp image of that object appeared on the mirror. The position is noted and recorded as Q. So they measure the position at which the image becomes sharp on the mirror. They record it as Q, and that's why this place is marked Q. So can we move on? The distance D between Q and the mirror is measured and recorded. A diverging lens L is then placed between Q and M at a distance X. So they now place what? This is the point where the image becomes sharp, QM. So a diverging lens is now placed between the mirror and the object now. All right, so what happened? We measure the distance X between the object and the lens. So let's move on yet. As shown in the diagram above, so we've seen it there. The position of a screen S placed behind Q is adjusted until a sharp image is formed on the screen. So this is the screen here. And we keep this one constant throughout the experiment. That the distance between Q and M is constant throughout the experiment. And then what we now start adjusting is the value of X. We start adjusting the position of the screen until we have the sharp image of the object on that particular screen. Are you getting that now? So what next? So let's go on. The distance Y between the screen and the diverging lens L is measured and recorded. So from here, that is from S here to this L, the distance is measured as what? Y. Are you following now? Now watch. The procedure is repeated for 4 other values of X. Figure 2A shows the position of the diverging lens Li relative to Q. So this is where we are going to get the reading for what? For the value of X. And then figure 2b shows the corresponding position of the screen S relative to the position of the diverging lens L. And here is where we are going to measure the value for that of the screen. Are you getting this now? So let's go back to the question. We already have the overview of the question now. We have understand that what we are to measure is what? X and Y. So let's now read the question so that we are going to know what and what will be on our table. So let's go back there now. An illuminated object O is placed in front of the reflecting surface of a concave mirror M. The position of the object is adjusted until sharp image coincides with it. The position is noted and recorded as Q. The distance D between Q and the mirror is measured and recorded. So distance D is equivalent to QM. It means we are going to measure the distance D, which is equivalent to QM. We need to measure that value. That's number one. What's next thing? After we do that, the position of the screen S placed behind Q is adjusted until sharp image is formed on the screen. The distance Y between the screen and the diverging lens is measured and recorded. So it means we are going to obtain the value of Y also. So what again? So let's move on. The procedure is repeated for 4 other values of X. So it means we are also going to measure what? The value of X, which is what? The distance from Q. So we have what? The value of X also to be measured. So let's go on. We are told that figure 2A stands for the value of X and figure 2B stands for the value of D. So the distance D of Q relative to the mirror, where I, so it means we are going to repeat the experiment 5 times. That is 1, 2, 3, 4, 5. So that's the numbers of time we are going to have the experiment. Then Roman figure 1, measure and record Xi, which is equals to QLI. So it means we are measuring the value of X, and then evaluate X inverse. So we are also going to have X inverse. Evaluate and record corresponding of Y. So we have marked that also. Evaluate Y inverse. So we are also going to evaluate Y inverse. Measure and record D equal MQ. So we have that already. Tabulate your reading. So let's quickly do that. So the first thing I'm going to do is that I'm going to draw, and here you have to be careful. You have to be sure of what you are doing so that you are not going to have anything cleaned. Just like this. So you have this. So make sure your table is very, very neat. And that's why it's advisable you draw with pencil first. So here you are going to create the top part of your table. At the top part of your table like this. Okay, I think let me have another page for this. And this is what I'm going to do so that you're going to get it clear. And for us to have a very neat job. So I'm going to take this as my rough page. The first one, that is when number 1, when I is 1, I'm going to get the value of X1. I'm going to get the value of Y1. So let's get started with that now. So what's the value of X1? So here is where I'm going to get the value of X1. So what I'm going to do is that, this is 0.0. This is L1, L2, L3, L4, and L5. So you place your ruler here like this. So make sure you place your ruler like this. Don't place it by side like this. Because if you place it by side like this, you are going to be having a parallax error. So place it here exactly. So like this. So you can see what I have now. So let the 0 be on this one. Then you can check where you have your reading. So this is 1 centimeter. This is 2 centimeter. You can see. If you see clearly now, you can see that this is what? 1.9. It's not exactly up to 2. So 1.9 is what we have here. Can you see that now? So your X1 is equal to 1.9. Then your x2, your y1 rather. So let's measure y1 also. Y1 is equivalent to s1. So place your ruler here. So when you place your ruler there, you check. This is s1 here. This is 2.5, and if you look at it vividly, you guys see that we have it on 2.6. Can you see that? So we record this as 2.6. So we go straight forward to x2, and then y2, x3, y3, x4, y4, x5, y5. So what's our x2 now? So they do the same thing, and we can pick the whole value of x now once. So place it here. All right, so here is what our x2. Can you see it here now? So this is 4, 4.5, 4.6, 4.7, 4.8. So that gives us 4.8. You write it down. Then the next thing is x3. This is 6, 6.5, 6.6, 6.7, 6.8 also. So you have 6.8. Then x4, which is L4 here. This is 9, 9.1, 9.2, 9.3, 9.4, 9.5. So you have 9.5. Then you go to the next one, 5. You can see the way I placed my ruler. Make sure it is placed like this, so that you'll be able to pick the actual value without any error due to parallax. So this is 11, 11.1, 11.2, 11.3, 11.4, 11.5. So you have 11.5 for that. So we are done with this. So the next thing to do is to measure that of y, and you just put the same thing there. So you can see this is S1. We have recorded the value before. Then X2. So this is 4.5, 4.6, 4.7, 4.8, 4.9. So you record this as 4.9. Then Y3. That is S3 here. So this is 6, 6.1, 6.2, 6.5 here. 6.6, 6.7, 6.8, and then 6.9 also. So this is 6.9. Then Y4, which is S4 here, this is 7, 7.1, 7.2, 7.3, 7.4, 7.5, 7.6, 7.7. So you have 7.7. Then Y5, you have 8, 8.1, 8.2, 8.3, 8.4, 8.5, 8.6. So you have 8.6. So we are done with taking the reading. But there is one reading we have to take now. That's the value of D, which is equal to what? QM. So, and where is it? This is point Q here. Can you see? And this is what? Point M. So you mark what's the value from point M to Q. So make sure everything align like this. And then this is point Q here. And this is 14. 14.1, 14.2, 14.3, 14.4. So QM is 14.4. Now, this is a rough page now. Have you seen that? So let me get another page for your table now. So since you've taken your reading now, so the next thing you want to do is to draw your table. And you guys to see the way I'm going to draw my own table. And it has to be very neat. Very, very neat. So this place, because D, which is equal to QM, is constant throughout the experiment. Are you following now? So it's going to be at the top of your table. So you say D equal, now QM equal, is it 14.4 that you are going to write? No, it's not 14.4, because if you check under this, always read this first before you start reading. You get to see that 1 centimeter represents 2 centimeter. What does this simply mean? For every 1 centimeter you measured here is equivalent to 2 centimeter. So if 1 centimeter equivalents to 2 centimeter, 14.4 is going to equivalent to what? That will be 14.4 multiplied by 2, and then you are going to have 28.8. So this one, instead of you to record what 14.4, you are going to record 28.80 centimeter. Why am I putting 0? Because the reading accuracy of a meter rule, when you are measuring in centimeter, it must be in 2 decimal places. And that is why you see this one, right? That's why you see me putting it in 2 decimal places, because I'm using a meter rule. Is that taken now? So once you're done with that, Roman figure 1. Remember, the question we are dealing with is under what? Under optics. So if you want to see the one under mechanics, you can check the link for the video in the description box below. And I think I do more explanation about alternative to practical in that particular video, so you can do well to watch it. I'll put the link in the description below. So let's move forward with this. So this is I, and this is X in centimeter. This is Y in centimeter. Remember, we are told that we are going to measure what? X inverse. Oh, but before X inverse, remember that we are converting this scale. So you put what? This one there, X centimeter in bracket, conv, that is convert. Y in centimeter in bracket, conv, that is a convert. Then you have a column for X inverse. This is X inverse in centimeter inverse. This is Y inverse in centimeter inverse. Have you seen that now? So these are the things that will be on your table. Are you following now? So you come back to where you have your reading. This is 1, this is 2, this is 3, this is 4, this is 5. All this column is not going to be in any decimal places. Are you getting this now? Because it's just a constant, Abi. So you know what? Go directly to your value. The x1 is 1.9. So here you come here, you write down 1.90. Remember, it is meter rule. That's why I'm putting it in 2 decimal places. Are you getting it now? So your x2 is 4.8. So I'll write down 4.80. And your x3 is what? 6.80. Your x4 is 9.80. This will be 11.50. Do you get that now? So you have to put it in 2 decimal places because you are measuring with meter rule. Are you getting that now? So any reading that you are picking, you put it in 2 decimal places. And any reading given to you in the question is going to be in what? 1 decimal places. Are you following now? So this one will also be 2.60. This will be 4.90. This will be 6.90. This will be 7.70, 8.60. Are you getting that now? So you now go for their convert. So this convert is the actual value. These are the picking value that you pick from the what? From the ruler. So now start converting by multiplying by 2. So we have what? 1.9 multiplied by 2. So that will give us 3.8. So you write this as 3.80. Then 4.8 multiplied by 2, you have what? 9.60. 6.8, sorry. So 6.8 multiplied by 2, that will give us 13.60. Then the next one is 9.8 multiplied by 2, that will give us 19.60. Then the next one is 11.5 multiplied by 2, that will give us 23. So 23.00. Can you see the way we are doing the conversion? So we are multiplying this one by 2 because we are told from the question that what? 1 centimeter represents what? 2 centimeter. And that's the reason for the multiplying by 2. So you have to always check this so that you know what the scale look like. And in some questions, they might not ask you to convert anything. You are just to what? Measure directly. So if that should be the case, we'll go for y now. So y now 2.6. So we say 2.60. 2.6 multiplied by 2. That will give us 5.2. So we have 5.20 here. Then for the next one, 4.9 multiplied by 2. So we have 9.80. Then the next one is 6.9 multiplied by 2. I have 13.80. Then 7.7 multiplied by 2. I have 15.40. Then 8.6 multiplied by 2. I have 17.20. So you are done with this. You are done with that. So the next one you want to look at now is to look for your what? X inverse. Make sure you don't shade. You make sure you don't. You can see as neat as it is. You must not paint, because this is the part of the exam that carries the highest mark. So anything that makes you shade here, you are going to lose that mark to that shading. Is that taken out? So you have to let it be as neat as possible. So let's go to the next one now to evaluate this. Now, if you want to find the x inverse means 1 over x. That's what it means. So which of the x are you going to use? You use the convert one. You are using the what? The convert one. So we start by saying 3.8. So sorry, it's going to be 1 divided by 3.8. And that will give us 0.2631. So here, you are to put it in either 3 decimal places or 3 significant figure. Note that 3 decimal places or 3 significant figure. So this will be 0.263. Have you seen that now? So that's what you put there. Then the next one, we said 1 divided by 9.6. And that will give us 0.104. So the next one, 1 divided by 13.6. And that will give us 0.074. Then the next one is going to give us what? 1 divided by 19.6. And that will give us 0.051. Are you there? So the next one is going to be what? 1 divided by 23. And that will give us 0.043. So we are done with this. So we do for what? That of y. And that will be 1 divided by 5.2. That will give us 0.192. And the next one, 1 divided by 9.8. That will give us 0.102. Now the next one, 1 divided by 13.8. So that will be 0.072. Then the next one is going to be 1 divided by 15.4. And that will give us 0.065. Then the next one is 1 divided by 17.2. So that will give us 0.058. So here is our reading. You can see it clearly now, and you can see how neat it is. So this is how you should have your reading. So what's the next question under this? The next question now says plot a graph of what? X inverse on the vertical axis against Y inverse on the horizontal axis. All right. I'm not going to be plotting graph in this video. I want you to plot the graph of this reading by yourself. Look at the reading clearly so that you can plot the graph by yourself. But when you plot the graph, you should be having something like this. So if this is the graph, so by the time you plot it, you should be having something that will pass through like this. So it's going to have what? Intercept on the horizontal axis and at the same time on the vertical axis. So when you plot your graph, you should have that. And if you still find it difficult to know how to plot graph, check the description box. I'll drop the video that I used to cover a detailed explanation on how to plot any graph in physics. What you have to do to plot any graph in physics. So let's see the next question. After the plotting of graph, the next one says determine the slope S. Everything is covered in that video, so you can get how to do everything. All right. So what's the next thing? State 2 precaution you would take to ensure accurate results if you were performing this experiment in the laboratory. Now this is fine. What are the precautions to take if you are performing this experiment in the laboratory? It's quite simple. What I'm going to do, if I'm doing it in the laboratory, now you have to write this as something you are going to do. It's not something that you do. So the first one is that I will ensure the object, the ray box, the lens, and the mirror and the screen, they are well aligned on a straight line. That's the first thing. Number 2, I will avoid parallax error reading meter rule. Number 3, I will ensure that the object is well erect, that is standing upright. So I think that 3 is enough for you. They ask you to what? State 2. So, and then if you want more videos on precautions, you can let me know in the comment section. So let's go to the section B now. So we are done with section A. Once we are able to answer all of those questions. So section B now says, what physical quantity in relation to the concave mirror in the experiment above is represented by the distance D? So let's check. What does distance D represent here? So distance D represents the radius of curvature. Distance D represents the radius of curvature. So what's the next one? A concave lens of focal length 12 centimeters. So you have to do all this calculation. So focal length F, that's what? 12 centimeter. Produce a real image 60 centimeter. So you have what? Your image to be 60 centimeter. That's the image height. From the lens, calculate the magnification of the image. So this one is just based on your what? Theoretical what? Understanding. So, and how do you do that? You can just go by saying what? Focal length is equal to 1 over u plus 1 over v. And from here, you can what? You can find your way to get the exact value for your linear magnification. And if you know you don't really have a concrete understanding of optics, you can let me know in the comment section so that I can make a detailed video on light wave. You can check the video. Maybe I'll link it in the description, the video on wave, so that you understand wave completely. Then I can make video on optics, that is light wave, if need be. So this is where we are going to stop. By God's grace, I'm going to be uploading that of electricity next. Then I will upload it so that you get to understand everything about alternative to practical. So this one is just for the optics. So if you have any question, let me know in the comment section below. Or if you want this particular manual in order for you to practice, you can also let me know by telling me in the comment section, and I'm going to pile up a lot of examples that you can just go and print out and then work with them. Thank you. Don't forget to subscribe, share the video, like and comment. Thank you.